We are streaming.
Excellent. Okay, 1 minute to go.
Really quick, David, are you excited about getting back to Global Star Party?
Oh, yes, I really am. It starts again next Tuesday. I've missed it and really looking
Yeah.
forward to getting back to it.
Yep.
All right, 7:30. Let's call this to order. Thank you everybody for joining us on a Thursday in October for the second to last third Thursday meeting of the year. Virtual Macomb, as we still call it. Perhaps one day next year we'll be able to go back to real Macomb, but with everybody apparently on the brink of another COVID surge, I'm thankful that we have a virtual meeting room in place of our small, cozy library. Okay, as your president, I would like to point out the following things. One, the fabulous calendars this year are available. Thanks to the diligence of Dale Teamy and Bill Beers on the calendar committee, they are out and ready to purchase. It's $15 a piece in person, correct? 20?
20.
20, okay. To cover the fact that we had to go with a new vendor this year and shipping costs aren't as cheap as they used to be. But it's still an excellent calendar. I need to pick up my own 3 copies at Cranbrook in a couple of weeks. And we hope that you can get them prior to January so you can enjoy the full year. Another announcement, next meeting in lieu of the short talk, it is our annual election. I've appointed myself chair of the election and nominating committee. Since I, as a third term president, am ineligible to run again. And quite frankly, after I've been on the board for that many years, y'all should be happy that somebody else has to take over. So, I would appreciate assistance as the election committee has to be at least, well, between 1 and 3 people. If you would like to assist with collecting nominations, putting the PowerPoint together, running the election, let me know. Otherwise, I can do it myself. Ken Burton has done that admirably for quite a few years on his own. And if you wish to...
Glad to do it again.
Thanks, Ken.
Okay.
And if you wish to serve as one of the 7 officers or have interest in being a subgroup captain, like say the audio visual czar that we very badly need so that we can have everything set up properly at Cranbrook while the board is doing their meeting and not have, about 2 minutes to set everything up before we go live at our Cranbrook meetings. So let us know, stand for office, run for office, make your mark on the club. Join the fun. This has been a great board. It's a pleasure to work with the officers who've been on the board for the last 3 years with me. And quite frankly, I don't know how we would have gotten through the pandemic if we didn't have such a good rapport with one another. So both the newcomers like Kevin and Adrian and the familiar faces like Riyadh and Bob and Mark and Dale Teamy and Dr. Dale, who was my program chair for a couple of years. Just it's a fabulous team. So step up. It'll be fun. And with that, I've got one other thing that normally would fall under outreach, but it's near and dear to my heart, and it's not technically something the Warren Club is involved in. So the newly reopened Belle Isle Nature Center will be having an astronomy event sponsored by Wayne State University Planetarium, the Nature Center itself, and Detroit Audubon. It's going to be this upcoming Friday, so tomorrow, 7:30 to 9:30. It's free with admission to Belle Isle State Park. So if you have a passport, it's free. Dr. Ed Cackett from WSU Physics, who's presented to us multiple times and is wonderful, will be giving a short presentation on the JWS telescope. And it'll be sidewalk observing in Detroit, which is awesome. Belle Isle is a nice dark site because of the buffer that the water gives it. So I don't know if I personally will be able to go out there, but I strongly encourage y'all to turn out for this, because if we could finally get up and running an active astronomical community using Belle Isle, that's something that I've wanted for many years. Jonathan, my partner, has wanted for many years. Bob Tremblay, I know you've wanted it for many years. It would be awesome. So check it out.
I just put a link in chat about that.
Thank you. Thank you, Bob. All right. So calendars are awesome. The elections are coming up. Belle Isle is awesome. And awarding people, recognizing their hard work, their curiosity, their generosity, their enthusiasm is also awesome. So we have received a couple of nominations for Distinguished Service Awards. We have the ability to give out the Searles Award for basically allowing the club to consume your entire life. Award that quite a few of my fellow officers have received, because that's exactly what we've done with our lives. The Larry Kalinowski Service Award for becoming part of the infrastructure of the club. The Blaine McCullough Award for enthusiastic newcomers who make the club a welcoming place, thereby making it sustainable. The Bob Watt Award for the hands-on worker who actually does the crafting, the teaching, the modeling, the modifications. And we have the ability to give unique Distinguished Service Awards for unusual situations above and beyond the call of the normal order of the WAS. So please submit your bids for worthy contenders to the board so that we can vote on it at our next meeting and make it a reality with a lovely plaque to place in the hands of these deserving individuals at our quote unquote banquet. All right. I think that's enough from the president's desk. I will pass things over to Bob Tremblay, your first VP.
Hi there, everyone. Our speaker tonight is Dale Partin. I have gotten for November Danica Remy. She is the vice president of the B612 Foundation, and she's going to be talking about asteroid defense. And I asked her recently, "You can talk about the DART mission, right?" She goes, "Oh yeah." So I'm also talking with Tim Campbell about him doing his spectroscopy thing. He gave that to us for a while, but he's updating it and including some stuff on the James Webb. So that is what's going on next month.
All right. Over to Riyadh at the Observatory Dome.
Thank you, Diane. Hello, everyone. We had our last open house on September 24th. Unfortunately, it was kind of cloudy, so we opened the observatory about 7:20 and we closed it at 9 p.m. We had about 5 people that attended altogether. We talked about the history of the club a little bit. We talked about the observatory and the telescopes that we have. Also, earlier, Jeff McLeod purchased and installed a wheeled trailer jack for our WAS trailer. So we thank him for that. Basically, all equipment and the building, everything is in good shape. And our next open house is scheduled for this coming Saturday, October 22nd. I'll be there probably around 6:30 or so to start. And as of now, at least, the predictions are for clear skies. So hopefully that will be the case this coming Saturday. So hope to see everyone then. Thank you, Diane. Back to you.
Excellent. Thank you, Riyadh. Okay, over to Mark Kedzier at the secretary's desk. Think you're still muted, Mark? Yeah, you're still muted. Can't hear you for some reason.
Mark, your mic itself may be muted. No, no dice, Mark. We still can't hear you.
Mark, would it be fair to say the minutes are in the WASP? Type out anything else that you need in the chat box, and I'll read it after we have Adrian give his treasury report. Over to you, Adrian.
Adrian is muted
Hey,
too. There you go.
yeah, all of a sudden I got hit with the same problem that Mark did. Can you all hear me okay?
Yes.
Can you hear me?
So I'm in a zone
Yeah.
that I need
Oh,
to.
Mark, did you just speak?
I spoke.
All right,
Okay.
Mark, back to
spoke.
the normal order of business. Let's hear from you.
Calendars, we have a total of 20 left, so don't be waiting till the last minute. So I'll have them at the Cranbrook meeting. And that's about it.
Very good. Sorry. Adrian, over to you.
All right. Well, real quickly, treasury business. We are still sitting on just under 30,000 in our account. I don't know that I have many things to process as far as reimbursements. I still do owe Mark Kedzier for the for some of the money spent for calendar fees. I also picked up the latest mail that we received from Mark, and we'll be going through that. Our memberships are still within the well over 100. At last count, I believe we were around 120 memberships. The remainder of the report is also in the WAS, and really quick for Astronomical League. A lot of the big things the Astronomical League has done has finished for the year. There are still online events, and the AL is also a big part of the Explore Scientific Global Star Parties, which will be restarting this Tuesday, next Tuesday, starting likely around 6 p.m. and going till 10 p.m. Eastern time. So feel free to join those. Myself, David, and sometimes others from the Michigan area give talks and presentations at Explore Scientific Star Party. Any other questions about membership or the Treasury? Just give me an email at treasurer@warrenastro.org. Back to you, Diane.
Fabulous, Adrian. Okay, do we have Kevin with us for outreach? Kevin's often working on Thursdays. Do send Kevin your outreach adventures so that he can put them in the WASP for the next month's report. I think the big things we have on our plate are, of course, the Stargate Open House and the Belle Isle event, if anybody's able to make it. So if you are able to make those events, do let Kevin know so that we can put it in the WASP. We also have, I think, we're already starting to get scouting requests for 2023 at Stargate, amazingly enough. So hey, we're fully back in business, and it's great.
Anybody know if Cranbrook is gonna start up their scouting stuff again?
No, we should probably ask, see if they're doing anything for the winter break. All right, over to Dale Teamy at Publications.
Well, the WASP is up online for the month of October, and as Mark pointed out, we're down to 20 calendars left, so you better get your orders in. The trying to think if there's anything else I got going on. Probably need to start work on the mailers pretty soon.
Ah, yes. Never ends.
Yeah,
Never ends.
and that's it for publications.
How many calendars did we start with?
50.
Very good. All right, so that concludes the officers' reports. As far as the subgroups go, Captain Marty of the Solar Group never joins us online. If anybody has an image of the sun, please put that in.
My bad. I'll get that.
No problemo. History group, got anything for us, Dale?
Not really. I was just thinking about trying to recreate one of the old ones based on other examples and put it as a filler until we get the actual thing in hand. But apart from that, I got no real projects going on.
All right. So we've got, let's see, the Double Star group will, of course, be meeting at the next open house with Riyadh at the helm, weather permitting. And the astrophotography group, I do see Doug there. What's going on?
I haven't done a whole lot this month. Just some solar work that I did early on.
Gotcha.
Bill's out of town, I think, this week. So,
Right.
okay.
Yep. And the weather is not being super cooperative. All right. Bob's got the sun, so we've got some visible spots here. Not as dramatic as
Yeah,
some earlier
there's
months, but
not a whole
there's
lot.
something.
But let's go back over to here because
Jupiter, of course, is looking phenomenal. And we've got the Orionids happening. Peak of the Orionids is about to hit.
a lot of prominence activity.
That's nice. Yeah, if you've got clear skies and good
Wow,
weather.
look what's going on in the upper left or upper right there.
Cool.
Coming back around. That
There's
thing
been some
wrote.
aurora activity as well, and due to
Yes,
this.
that's true, Dale.
Well, this means we're all on Aurora alert. So
Boy, that thing is flaring like crazy.
I'm planning on
What-
bringing my small astrophotography setup to the Stargate this Saturday.
Excellent. Okay, so history just oh yes, discussion.
Saturn's looking awfully nice too.
That's true. Discussion group. We earlier checked in with John and Rosie Blum if they were comfortable enough with the current state of the pandemic to see if they would host the traditional November get together at their house. The answer is no, which I completely understand. So we did do one backyard barbecue discussion group in July, and we haven't had any takers so far for indoor events. Again, we understand, but if somebody is willing to volunteer, say has access to a home or a workspace that is large enough where people can convene safely, with good ventilation, let us know. Let Jeff McLeod is our discussion group captain. Let Jeff know, and we will work with you. So, and I think that does wrap up our subgroup reports. So we can turn things over to observing reports. Raise your digital hand and let's see what we've got. I see two hands coming up from Dr. Levy, followed by Bob Tremblay. David, take it away.
Well, thank you very much. I'm still here and going to be having to leave fairly soon, but I do have a quotation for tonight. And this one is going to be in honor of the Orionids. And it's from King John. This shower blown up by tempest of the soul startles mine eyes and makes me more amazed that I had seen the vaulty top of heaven figured quite over with burning meteors. And speaking of burning meteors, we do have the Orionids coming up. And last night, for the first time in a while, I was able to get outside under the night sky and do a couple of hours of comet searching with one of my favorite telescopes. Thank you very much. Back to you, Diane.
Sounds very peaceful. Thank you. Over to you, Bob.
Not actually observing reports, more work related. A week ago, Brother Guy did an interview with Heidi Hamill, and I've been working on a podcast of that. I've been editing the audio and stuff, and it's absolutely delightful. And I'll let you know when it's up. But she was wonderful, and she goes into how she started with the Hubble and how she's ended up with the James Webb Space Telescope. One of the biggest things she did was observe the Shoemaker-Levy impact. And she said she was interviewed on the BBC the night before the impact, and they were like, she's like, I'm not expecting anything. Jupiter's big, comets are small. Maybe you'll see little white dots. And she says, I've never been more wrong in my entire life. And what's interesting is that there were several researchers who said, well, there's going to be big circular like tsunami plumes, and when it hits, you're going to see the plume rise up over the edge. And she was like skeptical of that. All those things happened. So it was a very good interview, and I'll post it when I get that done working on that podcast.
Fabulous. Who else has an observing report, or as we used to call it in the Union Hall, something else for the good of the organization?
I've got something. Let me see. I
Cool.
actually may be able to. So I'm gonna try and make this as brief as I can because I like to ramble on. Okie-Tex. Got a chance to go again. So seeing dark skies is always fun until they're no longer dark or clouds come. So we got a chance to observe probably the most rewarding moments for Okie-Tex. Last night we were actually at Okie-Tex. A gentleman and his son came up, and we shared views in the telescope. His son had a lot of questions about what he was seeing in the night sky. Um, it ended up feeling like an outreach event at that point, even though it was a dedicated star party. Very rewarding to show the night sky, especially a night sky like that. We brought the Michigan skies to Okie-Tex. There was humidity in the air, and you could see the difference from the beginning of the star party to when the humidity messed with the transparency in the seeing, to the point the sky was still dark, but you could see the difference in how it looked. We also decided to go to Black Mesa to camp out one more night, and the Oklahoma City Astronomy Club that runs Okie-Tex decided to do a view the moon event, and they set up right where we camped. So what did we do? We got out with a refractor and we joined their event, doing outreach, pointing to things in the sky. At first it was just the moon, but then we pointed to other objects, and a lot of people going, wow, and I've never seen something like that before. This blows my mind. None of that ever gets old. And one thing I noted about the sky is how well I could still see the Milky Way and a few other objects in the sky, despite that bright moon, crescent moon, rising in the middle of the Milky Way core. So it was nice to be out there with dark skies. It is a long trip home. I think most of us have either gone to something like that where the skies get really dark, but those who are on the meeting or listening to me, because I don't have my picture up, I recommend go at least once to one of these dark sky site parties. If you don't want to go all the way out west, you can go to closest thing in Michigan is the Great Lakes Stargaze. The skies do begin to get dark in the Gladwin area, especially facing north, and you will enjoy it. It will be an eye opener. Even being my second time, there's always something you can find, especially constellations that rise higher than they do here. Found a planetary in the constellation of Bruce, and that's a constellation that I don't know if it even gets over the horizon here in Michigan. So that's my observing report.
Fabulous. Anybody else? Digital hands? Any hands? Well, we got through the business part of the meeting in record time. It's only 7:53. Dr. Dale, would you be averse to going on at 8 p.m. or what?
That would work for me.
All right, gang, let's take a 5-minute snacky break in the comfort of your own home. Reconvene at 8 p.m. on the dot, and we'll let Dr. Dale have the floor.
I had a sort of a mini outreach / observing thing that I saw. Went
got?
to
Sounds
what was
good.
that?
Oh, what do you got? Oh, you can't hear
Yeah.
me. What do you got?
I went to I was on vacation. We went down to Missouri. On our way back through, we stopped at St. Louis, and we went up in the Arch. At the end of the night, they had a National Park Service ranger had a sort of a sponsored event with astronomy there, and they had, what was it called? I think it was actually the St. Louis. No, St. Louis. I think it was the St. Louis Astronomical Society. Someone brought out a fairly large daub. I think it was a 13-inch, and right there downtown. So it was very bright, but right through the arch in perfect sky conditions, really dry. And Jupiter was right next to the moon as it rose. I actually put up a photo on Facebook on the Warren page here, but it was fun seeing, obviously, in outreach when people who had never really looked through a telescope before. So they were looking at the moon and Jupiter and Saturn. That's all really you could see in the conditions. But Jupiter was perfectly placed right next to the moon inside the arch. There, it was pretty nice. So.
That's always cool when any kind of outreach, even if it's in the thick of the city like that, someone is always going to have their mind blown because it's the first time they've seen something like that up close.
Every time I've had my scope up, it's been the first time somebody's looked through it, which is cool and kind of sad.
Well, it is, but there's a lot more distraction online for people to
Well,
not look up.
my opinion is the first time somebody should look through a telescope should be in school.
Yeah, as a child, not a 50-year-old person. Like, hey, I've never
Exactly.
looked closely before.
Exactly.
Yeah, that goes into city priorities.
Yeah.
Here in Michigan, we're kind of lucky. We have a lot of places where even if the sky doesn't get to a Bortle 2, we approach Bortle 3 in some places north. We approach Bortle 2 all the way into UP, and we've got a number of dark sky preserves south, west,
We seeing that
north,
okay?
to north.
We seeing this video?
I'm seeing video.
Okay, good. I just want to make sure.
We're seeing it work.
That's for Dale.
Yeah, that's what the astronomy clubs are there for until the astronomy as a part of a curriculum gets back into the schools. Yeah, it's much needed. Oh, for those that are listening, David does have a new mic. Unfortunately, I didn't get the mic that we purchased for him to him in time. He ended up getting one, and I still have the mic we were going to gift him. We can put it to use for our own audio-visual stuff.
Why
It's
not?
a mic. We can try it. We can try it next Cranbrook meeting. I should be able to get there and hook it in and see what happens. We can give it a try and see how well it works, and work with the Cranbrook audio video guy to make sure we don't get any mic feedback. That would be bad. Last time I tried my copy of that mic, it fed back really badly. We ended up having to just shut it down. But it's a really good mostly omnidirectional mic. It picks it up from everywhere. There's your shot. That's a beautiful shot, Dale.
It's just an iPhone photo. I mean, I didn't get the tripod out or anything. So, I mean, the moon's overblown there, but you can see Jupiter. Here's all the people gathered around the Dob, and there was a big line. There's a 20 people probably waiting back off camera there.
Where was that?
St. Louis.
St. Louis, there's the arch.
Oh, that's the St. Louis Arch. Okay.
That's right. It's like Jupiter, the positioned perfectly there.
That's cool.
Standing back up to the thing, I can't quite see the whole arch, but the lighting is a little better here, a little bit higher in the sky.
Oh,
This is
you
back to the
have to
left.
submit that for the calendar next year.
Yeah.
Wow.
Yeah, that'd be a great. Those are all great
Yeah,
calendars.
those are amazing.
But just the experience there, it just the setting, the backdrop. I mean, you could see like one or two other stars here.
Yeah.
But yeah, it's inner city outreach is pretty much moon and planets. There's not much else.
Enough.
But you know what? Hey, for outreach, the moon is awesome for people.
Oh, hey, there is something I wanted to talk to you about. I'm going to be having a discussion tomorrow with another solar system ambassador who is trying to get the White House Astronomy Night restarted. And we've got the NAO and NOAA working on it, and we've got all of their previous contacts in the White House and the administration have vanished, so they're having to rebuild contacts and stuff. But it looks like we are building on getting a White House Astronomy Night, probably next year.
Where
So
they do have like a public thing and like the
yeah,
ellipse or the
yeah,
South.
exactly. And I was talking with the solar system ambassador today, and it's either going to be at the White House or at the vice president's residence, which I guess is easy to get to and has better parking.
It's the Naval Observatory. So the
Oh,
Vice
okay.
President's
Yeah.
house is the literal original USN.
Seriously? Okay,
Yeah,
that makes
that's
sense.
that's where VPs live. So that would be very fitting.
Isn't the observatory fairly close by? It's not like in the hills, outside the city or something.
Yeah, I mean, the original observatory site was picked by John Quincy Adams. Hilltop observing wasn't even a thing yet.
Yeah.
There's a reason their actual scientific operations are in Flagstaff these days.
You're right.
Foggy Bottom, not a good place to observe. Anywho, that's exciting, but it is now 8:01. So, Bob, in your capacity as first
Hold
VP,
on.
it's
Yeah,
time.
Yeah, it is. Hold on, let me get the darn thing up. Here I am, talking and not getting what I needed up. So Dale, you ready to go? Got your video. I got your video all queued. Oh, my internet is super slow today. What the heck?
Bob, when the video is done, I may want you to show it a second time, so don't X out of it.
Okay. Okay. So, Dale Partin is our speaker tonight. He is a Ph.D. from Carnegie-Mellon University, formerly did advanced research in the auto industry. He has over 80 scientific publications and 38 patents, and is a fellow of the American Physical Society, a member of Sigma Z?
Sigma Xi.
Xi, and the American Scientific Affiliation. He teaches astronomy at Macomb Community College here in Michigan, and he's been a member of the Warren Astronomical Society since 1998 and has frequently served as an officer. Tonight he's going to be covering the JUICE and Europa Clipper missions, and quick recap on that. The United States has been sending missions to explore Jupiter and its moons for 50 years now. Both the European Space Agency and NASA are preparing to send missions to explore 3 of the Galilean moons, Europa, Ganymede, and Callisto. Europa and Ganymede appear to have liquid water oceans under thick crusts of ice. Callisto may also have an ocean. The goal of these missions is to explore these moons and their oceans and determine their properties. The prime question is whether these oceans are suitable for life. It's also possible that these missions may discover actual traces of life if it's there. Dale, take it away. You want me to start the video immediately?
Yes,
All
and
right.
as Bob shows them, pay close attention to the magnetic fields.
Okay, there's the video and starting it.
You're seeing a model of Jupiter and its auroras. You're going to see Callisto. Here it comes. And as it passes through Jupiter's fields, you can see Callisto picks up an induced magnetic field around itself. Next, you're going to see Ganymede, which has its own magnetic field, plus Jupiter is going, and auroras, and Jupiter also induces magnetic fields in its oceans. Next will be Europa, which also does not have its own magnetic field, but one is induced in its oceans by moving through the magnetic fields of Jupiter. And Io is unique. It has this huge ion current circulating between it and Jupiter. It has volcanoes spewing out stuff which get ionized and form that ion current circulating to Jupiter. So that's a picture of the magnetic environment around Jupiter.
Not a healthy place for humans.
Right, as we will see. I guess I'm only going to need to see it once, Bob.
You want to see this part? Oh, that's the end of it.
No.
Okay. All yours.
All right, thank you. Let's see if I can get my screen up there. Share. Can you see my screen? Can anybody see
Yes.
my screen?
Oh, we see your presenter view with your slide deck and everything.
You don't see my PowerPoint screen?
We see your PowerPoint screen, but we see the version that I think you would see with your slides going down the left-hand side and your toolbar. Yep, there we go. Perfect.
Okay. Okay.
Not seeing anything.
Was that Ken? Did
I
you say
can't
you're
see
not-
nothing. Oh, there you go. I got
Yep.
it now.
Okay,
I can see it now. Okay.
so there are two missions that will be launching within the next year or two, heading for Jupiter to study its moons. And I guess before I get into this, I'd like to say, I think this is my third presentation this year. And quite frankly, it's a fair amount of work to put these together. But we need people who are willing to do it. So please, if you haven't done it for a little while, contact Bob Tremblay and he'll put you on the schedule. It can be several months out to give you plenty of time to prepare, but we need people to volunteer. So please consider that. Okay, so here I compare and contrast an image, the upper image that is roughly something like what we might see through an amateur telescope of Jupiter and its Galilean moons, with a very recent Webb image of Jupiter, which looks just beautiful, intricate. Let's see. So these are called the Galilean moons. Just a real quick bit of history. Obviously discovered by Galileo back in 1610. It gave strong support to the heliocentric model of the solar system. In the picture below, you can see that from one night to the next, the moons are whizzing around Jupiter fairly fast. First, I got into astronomy with a telescope back in 1997 and gave a presentation that year to the Warren Club. This is my data. On the horizontal axis is time. It's a little over 1 month of time on the horizontal axis. The center of Jupiter was at 0, and I measured how far each moon was each night and different times during the night from Jupiter using this eyepiece. Can you guys see my cursor?
Yes.
Okay. This is the reticle that's inside the eyepiece. I could use this linear scale to measure how far each moon was from Jupiter. And for example, the red sinusoidal wave is EO, back and forth. For some reason, this blue dashed line that shows the center of Jupiter is not exactly at 0. I don't know why. But you do this and you can figure out the period of motion of each of these moons. Here's the data I got. Here's professional data. Fairly accurate measurements. And I had not previously known it, but these moons are in resonance with each other. Here's J1, 2, 3, and 4. Europa's period divided by Eo's period is a factor of 2. So they're in resonance with each other. Ganymede and Europa also in resonance. Callisto and Ganymede, I think 2.33, which is 7/3. So I think it's also resonance. John Dumar, subsequent to that, did a more accurate study using a camera to take pictures of the moons and so forth, and lots of analysis. Gave a presentation 2 years ago on that. I think he was able to extract the mass of Jupiter to at least 5 significant figures from his data, something like that. And he and his students had given a preliminary presentation to the Warren Club back in 2016. So he really got bitten by the bug. This is the history of missions to Jupiter. I could have put 1 or 2 more on here. For example, the New Horizons mission that went to Pluto and beyond, went past Jupiter. But the first mission that ever went out there was Pioneer 10 and Pioneer 11 back in the early 70s, 50 years ago. They were both flyby missions, got there in less than 2 years, very lightweight spacecraft, and did not use gravity assists. Then there were the Voyager missions, also got out there really fast, even with a heavier or more massive spacecraft. This is the dry mass, not counting fuel, on the spacecraft that went past Jupiter. Then there was the Galileo mission, another decade later, which actually for the first time orbited Jupiter. And many of us remember the catastrophe that its main antenna was stuck and wouldn't open. And they had to use a tiny little antenna to radio data back to the Earth at a super slow rate. Nevertheless, by compressing pictures and stuff, they got a lot of good stuff out of it. It did use gravity assists. It took over 6 years to get to Jupiter. The Cassini mission flew by Jupiter on its way to Saturn. The Juno mission is still active now in an extended mission. It was there to study Jupiter, but now it's doing flybys of Jupiter's moons. And coming soon, the European JUICE mission and the Europa Clipper is kind of interested in how the different lengths of time it took for these various spacecraft to get out to Jupiter. That flight time is, of course, influenced by what rocket they used to launch the thing, how massive the payload was, did they use gravity assist, and also, was it an orbital mission or a flyby? If it's going to be a flyby, you can burn up a lot of fuel and whiz past Jupiter. You don't have to reserve fuel to slow down once you get to Jupiter, so you can put it into orbit. But if you're going to go into orbit, you want to fly slower to Jupiter, so when you get there, you don't need to use very much fuel to slow it down, so it goes into orbit. The European JUICE mission is going to be launched by an Ariane 5. Can put this much mass into low Earth orbit. NASA is going to use a Falcon Heavy to launch the Europa Clipper. It's going to expend the vehicle. It won't save fuel to come back and land, so they can get the biggest boost out of this thing they can put this 3 times more mass into low Earth orbit. Not that they're going to low Earth orbit, but that's just an illustration of the difference. Here's a scale model picture, the Ariane 5 versus the Falcon Heavy. So I'd like to compare the geological activity of these 4 moons. They're shown here in order. On the left is the one closest to Jupiter, and on the right, farthest from Jupiter. So the geological activity gets stronger and stronger the closer you get to Europe, to Jupiter. Io, I believe, is the most active world in the solar system. I've read that over 400 volcanoes have been discovered on it. You can see one of them erupting into space here. Europa, it's obvious, has an ocean under the ice. I was going to say underground, but it's under ice. Ganymede is believed to have an ocean under the ice. This based largely on data from the Galileo mission. And Callisto is a question. The Galileo spacecraft didn't collect enough data on Callisto to be sure whether it does or does not have an ocean. But
Gonna start a bidding pool?
the JUICE, I can't say it right, the JUICE mission will do some flybys of Callisto, and they should be able to figure it out. And this makes the point that the density gets lower of these moons as you move away from Jupiter, so they're more icy. Io has about the same density as our moon, so, and it's hot, so I don't think there's any water on Io. And JUICE is just going to study these 3 moons. Europa Clipper will study just Europa. So the Juno mission has, among other things, mapped out better than previously the magnetic field of Jupiter, which is what you see here, these lines coming out. And that magnetic field traps a lot of high energy particles orbiting Jupiter, just like similar to how the Earth has its Van Allen radiation belts. You can also see this, there's some plasma current, million amp kind of current circulating between Io and Jupiter. All these volcanoes are spewing stuff into space that gets ionized, and the magnetic field forms it into this kind of a circulation that contributes to the heating of Io. In somewhat more detail, There's an inner torus of radiation circulating Jupiter, consisting of oxygen and sulfur ions that came from Io. That's a really, really intense band of or belt of radiation. And Io is close to the center of it because it comes from Io. Outside of that, there are other ions. You can read the captions here. It's still very high radiation levels, but not as high as this. Europa is near to the center of that. So the environment, the radiation environment is still, I'll use the term bad at Europa. It's horrendous at Io. Ganymede is on the outer part of this. It's still in a radiation band, but not so bad. And then Callisto is in a low radiation place. So Juno is now on an extended mission. It had been just circulating Jupiter, coming in real close to Jupiter. So the radiation bands are out away from Jupiter. Juno was sneaking in close to Jupiter where the radiation was very low, which it's continuing to do, but now they altered its path. So it did 2 flybys of Ganymede about a year ago, I think it was. Kind of get 1 pass around Jupiter roughly on a monthly time scale. It's going to do 3 flybys of Europa. It just did one a few weeks ago. Here's a picture of Ganymede taken when it did a flyby of Ganymede. And on this extended mission, the plan is they're starting out at Ganymede and working their way into a higher and higher radiation environment. And at some point, the spacecraft may stop working from radiation exposure, but they're going to go all the way. The plan is to get all the way into Io and do 11 flybys of Io, where it's very dangerous to be. So this is a picture on the left taken by the Juno mission on its recent flyby of Europa. Lightly processed. A so-called citizen scientist took this data and enhanced it, both in contrast and in color. The picture is taken from almost 1,000 miles away with a not so great resolution. As you will see, some of the upcoming missions will get way better resolution than a kilometer. This is a schematic drawing of the magnetosphere of Jupiter. What is a magnetosphere? It's the region of space in which Jupiter's magnetic field is dominant, stronger than the sun's magnetic field, stronger than the magnetic field of Saturn or anything else nearby, stronger than the magnetic field of the galaxy. So the solar wind is coming in from this way, pushing on the magnetosphere, extending it out into a long teardrop kind of shape that extends beyond the orbit of Saturn. And interestingly, due to variations in the solar wind, it can make the tail of this thing wag by plus or minus 45 degrees. If you think how strong of a magnet would there have to be in Jupiter to cause all of this, it's called the magnetic moment. It's 20,000 times stronger than the magnetic moment of the Earth. Why is it so large? It's caused by the large heat flow from the core, which Earth also has, a extensive liquid hydrogen metallic interior. Hydrogen is under such pressure that it's squeezed down to where electrons come free from the protons and can move around and be electrically conductive. and a fast rotation rate that stirs all of that up. This is an amazing image. It's a composite of two pictures. This is a picture taken by the Chandra X-ray imager from a side view of the magnetosphere of Jupiter. Just huge, and it's superimposed on this ordinary picture of the moon and the Earth, of course, at the correct scale. So it's amazingly big. So we would be actually seeing the magnetosphere of Jupiter from this way, because we're in the direction of the sun, roughly, relative to Jupiter. So we would not get this side view if we could see it with our eyes or binoculars or something when looking up in the sky. So we would see it from this way. And if you ask how many degrees is it from one side of this to the other, it's 6 degrees in angular diameter as seen from the Earth. I mean, think about holding your hand at arm's length. I think if you hold up something like 3 fingers, 3 or 4 fingers, that's roughly 6 degrees. That's how big the magnetosphere of Jupiter would be tonight if you could see the magnetosphere. So on the right here, I put the radiation level at these 4 moons in sieverts per day. On Io, it's just horrendously large. Europa, several times better, but still terrible. Then lower on Ganymede and very low on Callisto. So the radiation on Europa is 70 times bigger than that on Ganymede. This is why the Europa Clipper will not be orbiting Europa. It'll continue to just orbit the planet Jupiter and come in for quick flybys past Europa, so that most of the time it's not in this high radiation environment. So it'll whiz by Europa and then spend something like a month out far from both Europa and Jupiter, and then come back and do it again. Whereas the European JUICE mission, after doing flybys of these 3 moons, will settle into a circular orbit around Ganymede because the radiation level is bad, but not so bad. Just to give you some calibration here, this is sieverts per day. An acute dose, that means a rapid dose over, say, a day or whatever, of 5 sieverts on a human is lethal for 50% of humans within 30 days. So half of anybody exposed to that radiation dose will die in 30 days or less. Many more will die after that 30 days from that radiation dose. Few of them will survive for years. On the other hand, and most interestingly for the present purpose, an acute dose of 10,000 sieverts, even 15,000, is survivable for some extremophile bacteria. So if there are bacteria of that variety that somehow are living on the surface of, say, Europa, they might actually be able to live there. I'm frankly surprised. And just to give you a comparison, this is the radiation dose of various conditions. Apollo 14 is singled out because that's the one Apollo mission that went straight through the Van Allen radiation belts. The others went not right through the middle of it, but kind of up over it a little bit, where they were still in it, but not in the most intense region of it. I also found out that there's a new proposed NASA radiation exposure limit for humans. I wasn't able to figure out if it's been finally approved, but everything I read said it was looking like it would be approved. The old standard of how much radiation an astronaut could be exposed to varied with age and gender. Women had a lower standard since radiation tended to cause cancer in them more than in men of the same age. And older people had a higher standard of how much they could be exposed to. The new standard that's probably going to go into effect, if it has not already, will be 600 millisieverts or 0.6 sieverts as a career limit, regardless of age or gender. For younger women, this is several times higher than what they were allowed to be exposed to before. But women were complaining because they couldn't go on as many missions as men could. I thought it was interesting that the Europeans, Russians, and Canadians all have this limit, significantly higher. And for calibration, a 3-year trip to and from Mars would give roughly this kind of radiation exposure, unless there's very thick special shielding. I read that NASA may simply require an astronaut to sign a waiver to go on those kind of missions. I don't know if that will fly or not as an approach to the problem. So, over a decade ago, there was a proposed NASA-ESA joint mission. After that joint mission would go into orbit around Jupiter, and ESA hitchhiker on it would separate off and go into orbit around Ganymede. The remaining NASA part would orbit Europa. That was the original idea. But back in 2011, Europeans looked at the NASA budget and didn't think they could ever do what they wanted to do within the limits of their budget. So ESA pulled out of that joint arrangement and decided to go alone with their own Jupiter mission to Ganymede, knowing that NASA had its heart set on studying Europa. So then NASA did decide to send a mission to Europa. So the ESA mission is called JUICE, Jupiter Icy Moons Explorer, which excludes Io, since nobody thinks there's ice on Io. So that mission was selected back in 2012. They had planned to launch it back, I think, in July of this year, which would have been really nice because the gravity of the other terrestrial planets were lined up very nicely to give them gravity assists. But they couldn't get things ready in time for that launch window. So the next opportunity where the planets align for gravity assists will be in this coming April, with arrival at Jupiter in 2031 using 4 gravity assists. I think they're even counting the fact that one of those passes by the Earth, they'll get a gravity assist, not only from the Earth, but from our moon. So the objectives are to study the emergence of habitable worlds around gas giants, characterize these 3 moons as planetary objects and potential habitats. And more broadly, they want to study the Jupiter system as an archetype for gas giant exoplanets. So they'll be studying the whole system, the rings of Jupiter, the smaller moons, not that they'll be going close to them, the whole system. This is the link to the video that I had Bob Tremblay show, in case you're interested in seeing it again. So this mission will have multiple flybys of these 3 moons, exploring potential habitats in subsurface oceans. After doing those flybys, it will then go into orbit around Ganymede in late 2034. I mean, you look at the times involved in these missions.
Whoa, it's going into orbit around Ganymede?
Yes.
Wow.
That's what I'm saying. Ganymede has a much lower radiation environment than Europa.
Well, I'm just thinking about the fuel requirements, because going into orbit around one of those moons takes a lot of fuel. It's a lot easier to orbit Jupiter.
Yes, it does take a lot of fuel. First, they'll put it into orbit with 5,000 kilometers altitude. Then they'll bring it into 500 kilometers altitude. And then they say they wish they would have enough fuel to drop it down to 200 kilometers, but they don't think they will have enough to do that. And ultimately, when they're low, very low on fuel, they're going to crash it into Ganymede to get rid of it. Takes less fuel to crash it into Ganymede than to bring it down in just such a way that they can stay in orbit around Ganymede. It has 10, or depending on how you count it, 11 instruments. I'm going to describe some of these instruments in a little bit of detail. It's 11 if you count the fact that there's a radio science experiment on board, supplied, by the way, by NASA. This shows which this Japanese outfit, who supplied some of the equipment for some of these instruments that the Europeans will be operating. One of these is not in parentheses. This instrument is not only being supplied by NASA, but a NASA scientist will be in charge of it during the mission. And I might add that all of these instruments are derived from similar instruments on previous missions. Often they're upgraded, but still they can trace their DNA back, some of them all the way to the Pioneer 10 mission, though they're massively improved from that. I say 11 instruments because this radio science experiment will be talking to an array of radio antennas on the Earth, which will do very long baseline interferometry to track accurately the position of the spacecraft as it flybys a moon. So there's more than I'm going to go through by far, but I'll give you a sample. They're going to image the surface of each moon of Jupiter that they fly by or orbit, not only to take pictures, but to do spectroscopy so they can get chemical composition. So they can do surface geology and composition, looking especially for vents or cracks where water comes out. They also have what's called a particle package. Where possible, they will try to fly through geysers or plumes of water coming out, which will immediately freeze into tiny, tiny pieces of ice. They'll study not only these particles, both individual atomic ions and sand grain sized particles. Not only will they study those particles, but electric and magnetic fields. The reason is those particles in general have electric charges. And from knowing what electric and magnetic fields they were being influenced by, they can track back to see where those particles came from and identify where on the moon those particles came from. So they'll be identifying what chemicals are ejected into space, and try to find out, again, where these things exactly are coming from on the surface. And then once they find that, they will focus their instruments on those places for special study. They have a laser altimeter on this European spacecraft. The NASA one does not, by the way. For mapping, you send very fast laser pulses down and receive the pulses when they come back up. And from the time difference, you can measure changes in the surface. If you can map the surface accurately, you can understand geologic processes, how much tidal deformation there is. If there's an ocean under the ice, then the tidal bulge they expect will be around 7 or 8 meters. But if it's all ice, then 10, 20, 30 times less tidal bulge. They will also do radar sounding. The radar they're going to have on the European spacecraft can go as far as 10 kilometers down into ice, trying to probe what the structures are like in the ice, and then if they're lucky, to see how thick the ice is and where the water starts. I have a sense that it's thought that on Ganymede, the ice is going to be a lot thicker than 9 kilometers. But if there are places, vents, cracks, whatever, where water can come up to the surface, they should be able to map that and see those structures in the ice. And also, the spacecraft, this is a real important instrument, a magnetometer, which will continuously monitor the strength and direction of the magnetic field. And as you may have noticed in the little video I had Bob show you at the beginning, only Ganymede has its own magnetic field. But all the icy moons, as they pass through Jupiter's very large magnetic field, as that field from Jupiter changes, it will induce electrical currents in conductive water. The water will have salts in it, various types of chemical salts, which will make the water electrically conductive. So as you pass this electrical conductor through a changing magnetic field from Jupiter, it will cause electrical currents to flow in the salt water. And those electrical currents will create their own induced magnetic fields. So you might think this is too subtle of an effect to be measured, but the Galileo spacecraft saw this stuff in its studies with its own magnetometer. But this is a much scaled up, improved instrument that these newer spacecraft will have.
Say, Dale, I got a question for you.
Yeah.
Is Jupiter's magnetic field and Ganymede's magnetic field fighting each other? Is it creating a torque? Could that be changing the orbit of Ganymede?
I didn't read about that, but I would say yes. Yes. The physics tells me the answer is yes. If you put two magnets near each other, they affect each other, right?
Now I got to go do some research.
So obviously that put a lot of emphasis on analyzing surface chemistry. using ultraviolet, visible, and infrared spectral imaging. Again, the UV spectrometer is going to have a NASA or an American principal scientist leading that effort to analyze surface chemistry, looking for places where material from the subsurface ocean has come up to the surface and analyze its composition, especially looking for, excuse me, organic compounds. And then I'll talk about this some more in a moment, but tracking an ultra-stable radio signal from the spacecraft using several radio telescopes on Earth to track its path very accurately to determine perturbations in the path due to gravitational non-uniformities in the moon that can be related to differing ocean depth and the depth of the ocean. That is, how far down below the ice is the ocean, and then how deep or thick is the ocean. Here's an example. This is using data from radar and a laser altimeter on Mars, using the data from the NASA Mars Reconnaissance Orbiter that's still orbiting Mars. This is two figures that are divided here. The upper figure is a radar trace. Here's 1 kilometer of depth for scale. This way, the scale is different. It's 100 kilometers this way. So you can see various layers in the ice down to the point where it hits bedrock. On the Galilean moons, they would hope to hit the ocean under the ice. This is data taken at the same time with a laser altimeter. As the spacecraft passes directly over this line above the moon, the laser altimeter is scanning back and forth, building up this image. So you can see correlations as directly under the spacecraft passes through these various features. You can see them show up in the radar image. Okay. So you get complementary information. This is pretty incredible. As the JUICE spacecraft goes past the moon, differences in composition, ice to water, for example, will have differing gravity fields that affect that spacecraft. So its path will not be perfectly uniform. What this instrument does is it measures the distance from the radio telescope to the spacecraft to an accuracy of plus or minus 20 centimeters. That's about 8 inches. It gets better because if this moon has some wiggles in this direction from differing gravity fields, they can measure a change in this velocity to roughly 1 to 3 micrometers per second. That's millionths of a meter. So they have incredible velocity resolution in this direction. They can also measure, so this is called linear or range position in this direction here. There's also lateral or transverse measurements of the position of the spacecraft, which using very long baseline interferometry from various radio telescopes, they can measure its position also quite accurately, plus or minus 100 meters in that dimension. This shows some old Galileo data on Europa. showing that there are different regions. There are some regions that are fairly flat and smooth and nice looking, and then there are these regions with random terrain. So different things are happening there. So that's the kind of stuff they want to study. What's going on out here and what's going on in here. Some of the science goals of Jews studying Ganymede are investigate the entire surface and subsurface and figure out what kind of geology has shaped the moon, get the composition and chemistry of the surface, look for biosignatures, look for where material is being exchanged between the surface and any subsurface liquid reservoirs. Figure out where material is coming up and study those places. And study the origin of the atmosphere, which may be coming from the ocean under the ice, and see where it's coming from and where it's going to, the stuff in the atmosphere. So now I'm going to talk about the Europa Clipper mission. Quite a bit of it is similar. Some of the instruments are pretty similar to those on the JUICE, so I'm not going to go into as much detail. The objectives are study this moon Europa, which for sure is a place where there's liquid water. Could it harbor conditions suitable for life? And by the way, do we see any biosignatures? They don't want to say that and go out on a limb and be criticized. And look for landing sites for a possible future Europa lander. I used to not think that much of that as a goal until I saw a higher resolution picture, which I'll show you, of the surface. So way back in 1997, NASA was thinking about a very versatile satellite that could sequentially orbit each of the 3 moons, estimated back then at $16 billion. Then a Europa orbiter was considered with a joint ESA-Ganymede orbiter. I mentioned that one before. That fell through, as I mentioned. In 2015, Europa multiple flyby mission, the Europa Clipper, was approved at $2 billion, now at double that. And it will use an elliptical orbit around Jupiter, not orbiting Europa, with 44 flybys to reduce exposure to radiation. They thought about including a Europa lander, and there were some people in Congress, I remember, saying they should do that on this mission. Somehow that didn't make it. And both of these missions are powered by solar cells, even though sunlight is about 25 times less intense at the position of Jupiter. But at least they're not going past Jupiter out to Saturn, where the sunlight is 100 times less intense than it is here on Earth. So one difference between the Europa Clipper and JUICE is they're going to have a fancier dual frequency radar that in one of its 2 modes can probe as deep as 30 kilometers into ice, produce a 3-dimensional map of ice and ocean. I'll have a thermal imager to look for warmer areas on the surface, which would locate potential vents of erupting water coming up through the ice. Some flybys will be as close as 16 miles for higher resolution studies and to sample water. You can see water geysers coming out here, imaged by the Hubble spacecraft. They want to go through those if they can, using a dust analyzer and an ion detector to get particle size, speed, and chemistry. This is the highest resolution picture ever taken of Europa, taken by Galileo from 335 miles away. So if this new Europa Clipper gets 16 miles away, that's 20 times closer. Europa Clipper will have 2 visible light telescopes, a narrow angle refractor telescope and a wide angle refractor. I'm sure they will shield this thing as much as they can to prevent the optics from getting darkened by radiation. But you can't completely shield it. It has to look out at the surface of the moon. As the spacecraft approaches the moon, it'll be taking pictures of some areas, and then as it passes, the telescopes will be rotated 60 degrees and take pictures from a different angle to allow stereoscopic images to be obtained so they can get a sense of how much surface height variations there are. So on a typical flyby, they'll map the surface with 50-meter nominal resolution, but at the closest flybys, have a resolution for the narrow angle telescope of 0.5 meter, 1.5 feet. Can't wait to see that. This makes the point, this picture, that the spacecraft will come in past Europa and its angle will be tilted compared to the plane of the radiation belts, so that it's mostly outside of the plane of the radiation belts. So again, they'll have a sensitive magnetometer, look for underground water, and an infrared instrument will map the chemical composition of the surface, looking for organic compounds and biosignatures. And they'll also use gravity radioscience experiments to probe the internal structure, see how much it flexes from tidal effects and its slightly elliptical orbit around Jupiter. This will depend on precisely tracking the spacecraft as it sends microwave signals back to Earth, sort of similar to what I showed you before for JUICE. There were other options that NASA was interested in to enhance the spacecraft. They asked ESA if they wanted to include a small detachable lander on the Europa Clipper to land on Europa. They declined. Requested proposals for other add-ons, such as CubeSats that could have passed very close to Europa or even orbited it. A larger probe that would have gone within a couple of miles of Europa to pass through water plumes. Craft with a magnetometer that would go in closer to examine the properties of an ocean. Having an impactor create a debris cloud that could be sampled by flying through it, possibly even with a sample return craft that could return material back to Earth. NASA even awarded funds to study these proposals to some parties that had proposals to do them, but ultimately none of these were selected. Having gone through all of this stuff, I look back at the list of what was on the Pioneer 10 spacecraft that was the first one to go out to Jupiter. A lot of the instruments were kind of similar to what we're sending now, but very crude. The electronics on that mission had very little, if any, shielding, and 5 of the instruments failed as it passed Jupiter on a single pass. I mean, this is a flyby mission. On a single pass, 5 instruments failed from radiation. It had a rather crude telescope on it, and the optics were darkened by radiation, but it was a pioneering mission. The ESA JUICE spacecraft will launch next year and arrive in 2031, taking 8 years. The NASA spacecraft will launch a year later, more than a year later, but arrive a year earlier, do many flybys of Europa. Nobody says it. I haven't seen this anywhere, but I have to think that there is some sense of competition between the two groups of the two organizations, NASA and ESA. You get a spacecraft out there first, get the first data with these more advanced instruments. We'll see if the JUICE mission launches next April and if the NASA mission launches here. If they do and nothing goes wrong with the spacecraft, the NASA spacecraft will get there a year earlier. I would add that originally Europa Clipper was going to launch on NASA's new Space Launch System rocket. This would have gotten the spacecraft to Jupiter in less than 3 years, in 2027. But delays with this rocket's development, and it's still having delays, caused and I think it was congressionally mandated that this Europa Clipper would fly on that Space Launch System rocket, but NASA somehow got it approved to switch to the SpaceX Falcon Heavy because the other rocket just didn't look like it was going to be ready.
I think the Congress person who mandated some of the things with the Clipper also lost re-election, so that may have impacted things.
Okay. So they're going to need gravity assists by Earth, Venus, and Mars, and take nearly twice as long to arrive at Jupiter. When the Europa Clipper runs low on fuel, the plan is to crash it into Ganymede. It will take less fuel to do that than to crash it into Jupiter, and they don't want to crash it into Europa. Just maybe, this is just me hoping, when they're preparing to crash the spacecraft into Ganymede, maybe they can do 1 or 2 flybys of Ganymede before the crash and use its radar to look more deeply into Ganymede than JUICE will. That's my story. Any questions?
All right. I've put a whole bunch of links to things he's been talking about in the chat.
Yes, Bob has been very busy with the copy paste.
Okay, thank you.
Excellent. I am very much looking forward to these 2 missions, Dale, even if I am a little bit leery of the potential contamination. You know, bad things happen out there in space. Do we have questions? Dale covered things very thoroughly, but these are cool missions.
So my granddaughter is going to be a teenager when these things get there, and
Okay.
an adult when the Uranus probe gets there.
All right, you didn't have to scare us all, Bob.
Sorry.
Well, great stuff. Do you have a preference between the 2 missions, Dale? Like, are you rooting for them equally, or is one of them a little more near and dear to your heart?
I'm equally interested. Each of the missions has its strengths. The fact that the European mission is going to be able to orbit Ganymede is great.
That blows me away.
I mean, I think they're going to learn a lot. I gave a somewhat related presentation earlier. And back then I was critical of some aspects of what they're doing, but having looked more deeply into it, I have a lot of respect for both of them. I hate to put it this way, but I hope I'm around to see how it goes.
Well, now that Bob has put the fear of Father Time into it, I hope we all are.
Do we think that we're going to be able to seed Ganymede with life from the bacteria that's on the ship? Because if you got a problem there, you might have a problem there too.
Well, I'm sure that measures will be taken to sterilize these satellites.
Hopefully.
I don't think they will be completely sterilized. I think it's very difficult to do that.
Right.
Yeah, my understanding was very difficult was an understatement.
Yeah, it's basically impossible.
Yeah, there you go. That going into Jupiter would certainly help it, but I understand.
So I think there's more fear of contaminating Europa than Ganymede because the ice is surely thicker
No question
on Ganymede. And by the time they're ready to crash these spacecraft into Ganymede, they'll have mapped the surface.
Okay.
They'll probably pick a spot to hit Ganymede that's not close to a crack or a vent. They'll do the best they can.
Yeah. Well, okay. Better than sending humans there.
Well, it'd be tough to send humans there. The radiation is too fierce.
Yeah.
Right. Great talk, Dale.
Humans would be like what, a quarter of their life to get there and back, and then they've got all the radiation to deal
You'd
with.
have all kinds of fun radiation sickness by the time you even got halfway out.
Yeah.
I mean, it's very difficult to get people to Mars.
Yep.
And back, not only because of radiation, but if they're not going to be centrifuging them, how do you like to arrive on Mars and you can barely walk?
Walk, right.
Barely walk, lost your vision, things going on with your blood. Yeah, no thanks.
Starving because you're running out of food.
Yeah. All right. Well, thank you very much, Dale.
My pleasure.
If anybody wants a related B quality science fiction movie related to Europa, you can watch Europa Report, and it has monsters, so watch out for that.
There's a old Sean Connery movie called Outland where he plays a marshal on EO.
Okay, Bob, Dale, mail those to me at presidentwarrenastro.org because once I've hung up my presidential hat, I want to go back to writing movie reviews because I don't have time to do that, and I really enjoyed it. So I will kick off the new year with some terrible movies, thanks to y'all. So please mail me.
There's also the 2061, the third Odyssey, I think it is, Arthur Clarke's continuing thing from 2001, where they actually landed on Europa. So if you've not read the novel, I don't know whether they made a movie of that or not.
All right, gang. Well, now I've got some homework for myself for next year, but good seeing y'all. Close things up a little early tonight, even though Dale had the full hour and then some. And we'll see y'all at Cranbrook.
Good night.
Have your election
Good night,
hats
all.
on.
Night, everyone.
Oh, and don't forget, tomorrow is the Belle Isle thing, and Saturday is Stargate. So if the weather holds, head on out, bring your scopes, have some fun.
So what's this Belle Isle thing? I got to the meeting a couple minutes late.
Oh, it's cool. Basically a coalition of people who've been working very hard to make Belle Isle an official dark sky site. Bob and I have been involved on the periphery, but we've been so overwhelmed we haven't, made any of the decisions. But we're part of this team nominally. Are starting to have Belle Isle star parties. So this one tomorrow night is Wayne State Planetarium It's the Belle Isle Nature Zoo, which is newly reopened after a massive renovation, and the what's the other org, Bob? It's Wayne State, the Nature Center.
Yeah, I only know about Wayne State.
Okay, it's a three coalitions are putting it on. Anyway, it's cool. So Ed Cackett, friend of the club, frequent presenter, is going to be giving a talk at the Nature Center. People will be out there with their scopes. And thanks to the Lake St. Clair, right up, north of it, the skies there are pretty dark. So, well worth the time, in my opinion.
Diane, get a hold of me when you can about the election for the material I got to put together for you. Okay.
Sweet, will do. Thank you, Ken.
All right.
All right. Night, y'all.
Good night.
Night, everyone.
Right. Very
Right.
good presentation, Dr.
Night,
Partin.
everybody.
Thank you.
Great comment. Yes, absolutely great.
I'm gonna have to see if I can see that Europa report. I haven't seen that.
I don't remember very much about it. It's sci-fi / horror. Things don't end well, and there is life. So, but I think it's like the second mission, they find something the first mission, second mission go back with like a submarine. So, yeah.
Wow, that would cost a lot of money to send to Europa. Holy mackerel.
Yeah, people, equipment, yeah. So,
Submarine.
but yeah, I guess it's from